Hey everybody, video number 3, final video on the trapezoidal rule. Back of your packet, an example using the trapezoidal rule. This is what your homework will be like, so let's take a look. It says, use the trapezoidal rule with n equals 3 to estimate the definite integral from 1 to 4 of x squared dx. So what we need to do here is we need to graph x squared from x equals 1 to x equals 4. So let me map this out on this graph. I am going to kind of draw my y-axis right here, my x-axis here. And if I'm graphing x squared between 1 and 4, let's see here. I don't know if I just want to go by ones here. I could spread this out a little bit more. Could I go by 1, 2, 3? Yeah, let me go every 4. It's almost like I'm making quarter unit intervals. So if I go, I'll make this 1, make this 2, make this 3, and make this 4. Now I'm not going to be able to do the same thing on the y-axis because, as you know, 4 squared is 16. So I think I'll just go by ones on the y-axis, or the f of x-axis. So let's trap this between 1 and 4. So 1 squared is 1. So I'm just going to be like right here. 2 squared is 4. 1, 2, 3, 4. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 4 squared is 16. So 10, 11, 12, 13, 14, 15, and 16. So you can see that quadratic between 1 and 4. A little bend to it there. Okay, so there's my quadratic. Now, my trapezoidal rule, I'm using n equals 3. So I need to get into the mechanics of the formula. So what I'm going to do underneath here is actually write down the trapezoidal rule from up top here. So let me remind myself, a trapezoidal approximation will take my delta x and divide it by 2. And then it will sum up a bunch of y values. It will use the initial y value only once, the next y value twice, the next y value twice, because it's going to be used in 2 different trapezoids, and etc., etc., etc. And then the second to last y will be used twice, and the final y just once. So this is my formula. Now I just have to use it specifically for this problem. So let's start by finding delta x. We know delta x. Delta x is b minus a over n. In the case of this problem, my b is 4, my a is 1. So 4 minus 1 divided by n is the number of trapezoids I'm making, which in this case is 3, and 3 divided by 3 is 1. Okay, so that's my delta x. So I'm going to plug that in. So t is approximately 1 divided by 2 times. Okay, let's grab that initial y value. The initial y value is the y value when, at our starting point, when x is 1. So I know that's 1 squared, which is 1, plus 2 times my next y value. Now, if my delta x is 1 unit, then I'm going from 1 to 2, so my next y value will be here at x equals 2, and I know that that is 4. So here's my trapezoid. That first trapezoid sits right here. You can see it. See that trapezoid? Okay? Plus 2 times the next y value. Well, my next y value will be at 3. So I'm going to come up at 3, grab the height there, connect. There's my trapezoid. So that height is 9. And then my final trapezoid just runs from 3 to 4. Come up, grab that, and here is my final trapezoid. So I only have 3 of them, each one unit here on the delta x, and that final height I don't need to multiply by 2, I'm just going to put 16. Now you can see the mechanics here, check it out. So if I fill in this first trapezoid, see how your y sub 0 is only used once, but your y sub 1 is used twice. It's used in this trapezoid and the next trapezoid. And then see how your y sub 2 is also used twice? It's used in the second trapezoid and the third trapezoid. But your y sub 3, your 16, is only used one time. Awesome. So, trapezoidal rule, 1/2 times. Let's see, we've got 1 plus 8 plus 18 plus 16, which is 1/2 of 43, or 21.5 units squared. So this is the estimated area, pink here. Now you can see it's an overestimate. See how the trapezoids slightly overcompensate for the true area. You can see the error right here. I'm going to go over it in red. See right here, because of the nature of the quadratic, right here we have a little bit too much, here a little bit too much, and here a little bit too much. Okay? If I was to use the mechanics of the fundamental theorem of calculus, I would see that if I anti-differentiate x squared with respect to x from 1 to 4, I would get 1/3 x to the third from 1 to 4, and if I plug the 4 in, I get 64/3 minus, plug the 1 in, I get 1/3. That's 63/3, which is 21. So look at how close I am. 21 units squared versus 21.5 units squared. I'd say that's a pretty good approximation by the trapezoidal rule. So there you have it.